Hello everyone, welcome again to my channel. Today let's solve this equation which reads 1 to the power of x is equals to 5. What is the possible value for x? This question looks somewhat crazy because we are saying 1 to the power of x is equals to 5. What is the possible value for x? So how can we solve this? So if you are new here, subscribe to this channel and turn on the notification button so that you get notified whenever I drop amazing challenges on mathematics. So let's see how we can provide a solution to this. The question again reads 1 to the power of x is equals to 5. Looking at this equation very well, we can't really directly solve this because it looks somehow impossible to solve. But we are going to use what we call the Euler's identity to solve out this. What does the Euler's identity say? So we can say solution. Okay, the Euler's identity says if we're having exponent of pi I plus 1, this is 1, equals to 0. Okay, so if we should bring it here, we can write this to be exponent of pi I is equals to minus 1. Okay, so this is what we're now having. This is the Euler's rule. So, but if you look at this equation very well, we're having 1 to the power of x is equals to 5. Okay, we're having 1 to the power of x equals to 5. So how can we solve this? And if we are using the Euler's identity, which is exponential pi I plus 1 is equals to 0, then we said exponential pi I is equals to minus 1 by bringing this to the right hand side of the equation. But seeing this, we are having 1 to the power of x. 1 to the power of x. So if we are having this, the next thing is to work on this rule. So we can say exponential pi I equals to minus 1. Okay, minus 1. So the next thing we are going to do is to take the power of both sides to the power of 2n or to the power of 2n. So having this, we can say exponential pi I or to the power of 2n is equals to minus 1 or to the power of, this one is 1, 2n. Okay, working on the right hand side, we are going to apply a rule which says if we are having a to the power of bc, okay, it's also equals to a to the power of c or to the power of b or to the power of c. So if we put this principle here, we have this to be exponent of pi I or to 2n equals to minus 1 to the power of 2, okay, to the power of 2 or to the power of n. Okay, so this is what we are now having. Okay, recall that your minus 1 or to the power of 2 is also equals to 1. So from here we can say exponential pi I or to the power of 2n is equals to 1 or to the power of n. Okay, or to the power of n. And we said 1 to the power of n. Recall 1 to the power of n is also equals to 1. So from here we're having exponential pi I or to the power of 2n is equals to 1. So our 1 is equals to exponential pi I to the power of 2n. So at this point we are going to apply the rule which says a to the power of b or to c is also equals to a to the power of bc. So if we put this rule here, we have this to be exponential 2n pi I is equals to 1. So coming back to our equation which says 1 to the power of x is equals to 5. So in the place of 1 we are putting exponential 2n pi I. So write this to be exponential 2n pi I or to the power of x, okay, equals to equals to 5. So we are not having this, we are not having this, we are not having this. So since we are having this, what are we simply going to do? What are we simply going to do? So we can put this rule here again, which says we are having a to the power of b, a to the power of bc, or to the power of d, okay, it's also equals to a to the power of b, c, d. So if we put this rule, this simple rule here, we have this to be exponential 2n pi r x is equals to 5. Okay, so we've done this, we are going to take the ln of both equations. So if we take the ln of both equations, we say ln exponential 2n pi r x is equals to ln 5. So we can see this exponent will cancel this ln. So we are now left with 2n pi r x is equals to exponential 5. So from here we are now having 2n pi r x is equals to 5. Okay, so let's make s the subject formula. So therefore we can say x is equals to 5 over 2n pi r. So this is the value for x, where your n represents your nth number, where your n represents your nth number. In other words, if you pick any value for x, if you pick any value for n, assuming n is equals to 1, and you plug into this place, it's going to give us the digit value for x. So if you find this video useful and interesting, click on the subscription button. Bye bye, and see you in my subsequent